Okay, so we're going to be looking at 9-7. We're going to be solving inequalities, one variable. Here are the objectives. We're going to graph them on real numbers, graph the intervals of real numbers. We're going to solve linear inequalities of the form ax less than c and x plus b is less than c. We're going to solve them for ax plus b less than c and ax plus b is less than cx plus b. So just one variable may be on both sides of the equation, but there's only going to be one different letter to deal with. And then we'll use linear inequalities to solve applications. So we got a few word problems. So let me point out what's important here. First thing is we talk about the interval of real numbers. Okay, whenever you have this less than, greater than, less than, or equal to symbol, it's called an inequality. So that's what we're referring to. And then you have some notations and symbols. So you have open interval, which is dealing with strictly less than or greater than. There's no equal to on the inequality. The endpoints would be parentheses, and this is what it would look like graphically. We'll do several examples together. You have what they call closed interval, which is inequalities with equal to, and those will be identified with brackets, which means the endpoints are included. And then you have some that are half open and half closed, which I just call it a half open interval. And half open, you have one with equality and one without equality. So one bracket, one parenthesis, it could be on either side. And then you might have a double open interval, so you have two parts, so one going one direction, one coming the other direction. And then you also have a half open interval with the same scenario. So here's the wording of the book. It's just showing you open interval means neither endpoint is included, and then you also have closed interval, both endpoints are included, and then half open, one endpoint is included. And it also tells you for infinity when the inequality goes on forever, either to the negative or to the positive side. We denote that with this infinity symbol, which looks like a sideward 8 or figure 8. So you have positive and negative, just puts a number in front of it. It said this is not a number. Okay, so you will never include that in the endpoint. So infinity will always have a parenthesis, it will always be open. Okay, so here's examples that you can look at. I just kind of want to point out the description of solving it. So down here, the addition principle. So basically, you'll have x on one side and a number on the other side. If we have to move a number or add something to cancel something out, the addition principle is just saying that whatever you add to one side, if the left side is less than the right side, if you add the same thing to both sides, the left side is still going to be less than the right side because it's the same thing. Okay? So just for an example, if I have something like 2 is less than 3, and then I add 5 to both sides, basically I get something that's still true. 7 is still less than 8. So I added 5 to both numbers, and both of those are still going to be the same truth value. So that's all that's wanting you to see here with symbolic notation. And then there's another principle. These are some more examples, which we'll do a few, which they call the multiplication principle. So this one is saying that if you multiply both sides by the same number, that this is saying, hold on, if you have these numbers A and B, and C is a positive number, so I need to be careful here. So first we're dealing with a positive number. If you multiply both sides by a positive number, okay, the truth is still going to be the same. And then down here it says if you multiply the expression by a negative number, okay, then the inequality is going to get flipped. So as you see here, it's A less than B. If we multiply by negative, I think this wants to say then the sign of the inequality is reversed. Okay, I'm not sure if sense is correct. but I think it's the sign. So here's the inequality sign. When you multiply by negative, it gets reversed to the other direction. So just to kind of see what this is doing by hand, so I'll give you another example. I'll still use 2 and 3. 2 is less than 3. Okay, so this is what we're starting with. If I multiply both sides by 4, okay, then I will still have that 8 is less than 12. Okay, this is still true from what we started with. Now, if I were to multiply by a negative number, so if I start out with 2 is less than 3, and then I multiply by, let's say, negative 4, okay, whenever we do this math, this becomes negative 8. We also have to flip this guy, and then we have negative 12. So here, negative 8 is actually greater than negative 12, and if you don't flip it, it'll come out incorrect. So be careful with that. That's what this multiplication principle is wanting you to see. And then a few more examples here, and I think they give us the problem-solving steps. So here's the last thing I want to point out. Steps for solving. You're going to combine like terms, and they say use the addition principle. So either we're going to add, or we may have to subtract something from both sides. So kind of like here. This is that first thing we did. We added the same thing to both sides, or you might have to subtract, so that the variable is on one side and the constant or the numbers is on the other side. After that, you actually do the multiplication, or they say division principle. So we will either multiply, which you can say multiply by the reciprocal, or divide both sides by that same coefficient, so that we can solve for that variable. So it says if the coefficient is negative, be sure to reverse the inequality sign. So this will be a good, handy thing to have written or have next to you when you're solving them, kind of point you what to do. And from this, we should be able to go solve. They just show you several examples here, but we will be doing examples here in Hop. And then some application problems, which we'll go through all of these, and you have these extras to look at.